Hello everyone, welcome to my channel. I am Krishan Dupine. In the previous videos, I have solved the question number 12 to question number 20 of CMI M.Sc Data Science 2018 paper. In this video, we are going to solve the first 10 problems from the part B. So, let's begin. Question number 1. N is the set of the natural integers and f is a function from n cross n to n. It is defined by fmn equal to 2m minus 1 into 2 to the power n. So we have to find is f injective or is f surjective or both. Let mn and xy, these are 2 points from n cross n. Suppose f of mn equal to f of xy. From this, if we can prove that the point mn equal to the point xy, then we can conclude that f is injective. So let's see. So we have written the forms of f here and here. Now this 2m minus 1, 2x minus 1, these are the odd parts, and this 2 to the power n, 2 to the power y, these are even parts. So the two terms to be equal, we have 2m minus 1 equal to 2x minus 1 and 2 to the power n equal to 2 to the power y. The odd parts has to be equal and the even parts has to be equal. Then from this we can get m equal to x, from this we will get n equal to y. So we are getting mn is equal to xy. So f is injective. Now we have to see that is f surjective or not. So suppose take any point A belongs to n. N is the set of natural numbers. As a belongs to n, if we can find any point mn from the set n cross n such that 2m minus 1 into 2 to the power n equal to a, then we can say that f is surjective. But suppose take any odd integer which is natural number. Suppose take a equal to 5. I am taking just an example. You can take any odd integer. To be equal to such term, it is an odd integer, then this part is an odd integer, this part is odd and this part is even. So a to be an odd integer, we have to equate 2m minus 1 with a. So this odd part can be 2m minus 1 and the 2 to the power n, this part should be 1. But 2 to the power n equal to 1, this means n is equal to 0. But 0 does not belong to the set of natural integers. So f is not surjective. So the answer is f is injective but f is not surjective. Question number 2. A, B, C are m cross m matrices. There is an algorithm given where Aij is the ijth entry of matrix A. For I equal to 1 to m, j equal to 1 to m, k equal to 1 to m, there is given Cij equal to ajk into bkj plus cij. Now I am taking one instance. For I equal to 1, j equal to 1, for k equal to 1, it is computing c11 equal to a11 into b11 plus c11. For k equal to 2, it is computing c11 equal to a12 into b21 plus c11. This c11 is actually this one. So by this process we are calculating AB plus C, this matrix. How? Because for k equal to 1 to m, this is actually computing the matrix multiplication of the matrices A and B. This I condition is actually going through the rows, this j part is going through the columns, and k is calculating the product of the matrices A and B. So by this algorithm we are calculating AB plus C. C because we are calculating this Cij part with each of the iterations. So this is calculating AB plus C. Question number 3. A matrix A is given. We have to find a to the power 10. So this is an upper triangular matrix. The eigenvalues of this matrix are the diagonal elements. So the eigenvalues are 1, 1, 1. So the characteristic equation for A is x minus 1 whole cube equal to 0. So A also satisfies this. So this will be A minus I whole cube equal to null matrix, which implies A cube minus 3A square plus 3A minus I equal to null. Now we can write this as A cube minus A square equal to 2A square minus 3A plus I. Now multiply A to the both the sides. So we'll get A to the power 4 minus A cube, which is equal to 2A cube minus 3A square plus A. Now if we put the value of A cube as 3A square minus 3A plus I, we will get 3A square minus 5A plus 2I. Again multiply A both sides, we will get A to the power 5 minus A to the power 4, we will get 3A cube minus 5A square plus 2A, and again if we put the value of A cube as 3A square minus 3A plus I, we will get 4A square minus 7A plus 3I. So you can see there is a pattern, like the coefficient of A square is getting added by 1, 2, 3, 4. The coefficient of A is increasing by minus 2, minus 3, minus 5, minus 7, and coefficient of I is increasing by 1, 1, 2, 3. So with this trend we can conclude that A to the power 10 minus A to the power 9 is equal to 9A square minus 17A plus 8I. How we can do this? Because this is the trend, like A to the power n plus 1 minus A to the power n equal to n square minus 2n minus 1A plus n minus 1I. Now if we add these terms like A cube minus A square, A to the power 4 minus A cube, A to the power 5 minus A to the 4, like dot dot, there are other this type of equations, and last A to the power n minus A to the power 9 equal to this. So we will get A to the power 10 minus A square, which is equal to 2, here is 2 plus 3 plus 4 dot dot 9 A square minus 3, 5, 7 dot dot 17 A plus 1 plus 2 plus 3 dot dot 8 I. If we calculate this, we will get the value of A to the power n minus A square. Take this A square this side, so we will get 1 plus 2 plus dot dot 9 A square. This sum 3 plus 5 plus 7 dot dot 17, it is actually equal to how many number of terms are there? 8 divided by 2 into first term plus second term, which is 20 A. Similarly here n into n plus 1 by 2 I. So it will be equal to 9 into 10 by 2 divided into a square minus 80A plus 36I, which is 45A square minus 80A plus 36I. If we calculate A square, 1 to 1, 0, 1, 2, 0, 0, 1. So if we put these values of A square, A and I, we will get A to the power n equal to 1, 10, 45, 0, 1, 10, 0, 0, 1. This is the answer. Question number 4. A floating point operation flop is any one of the following operations performed by a computer: addition, subtraction, multiplication, division. The dot product between the two vectors u, v, w and x, y, z is, this informs 3 multiplications: u with x, v with y and w with z, and 2 additions: ux, vy and w. A total of 5 flops. We have to calculate the exact number of flops required computing C equal to AB of two 5x5 matrices A and B using a direct implementation of Cij equal to summation k equal to 1 to 5 aik into bkj. For k equal to 1, there is one multiplication. For k equal to 2, there is one multiplication. So similarly for k equal to 5. So for this, to get Cij, we will use 5 multiplication, and there will be 5 numbers, so we will have to add them. So we will use 4 additions. So there will be 9 flops for one element Cij. This is a 5x5 matrix. So total number of elements is 5 into 5, 25. So we will have to use 9 into 25, which is 2 to 5. Total 2 to 5 number of flops we have to use to calculate C equal to AB for two 5 cross 5 matrices A and B. If both the matrices are upper triangle, then we will have this kind of shape where this part is, there are some numbers, and this part is all 0. Now to calculate C11, that means the first element, we have to just multiply this point and this point because there is 0 for the other points. So for C11 we have to calculate just one multiplication. So there is one flop. For C12 there are two multiplications and one addition, so total 3 flops. Similarly C13 there is 3 multiplications, 2 additions, total 5 flops. So similarly for the first row, total number of flops are 1 plus 3 plus 5 plus 7 plus 9, which is equal to 25. To calculate the second row, as these two matrices are upper triangular, so the product matrix is also an upper triangular matrix. So C21 it is 0, so we don't have to calculate any. For C22 there is again only one multiplication. C23 2 multiplication and one addition 3. So similarly for the second row we have to calculate 1 plus 3 plus 5 plus 7, which implies 16. So similarly for the total 5 rows we have to calculate, for first row this is 25, for second row this is 16, for the third row this is 9, for the fourth row this is 4, fifth row is 1. So this total is 55. So if those matrices are upper triangular, we have to use total 55 number of flops. Question number 5. A is a set consists of these 4 points A, B, C, D. Function f from set A to itself is said to have a fixed point if fi is equal to I for some I in it. We have to find the number of bijective functions from the set A to itself which has no fixed point. Total number of bijective functions from A to itself is 4 factorial because there are 4 terms, so this is 24. Now we will calculate that for this function f, how many ways there can be one fixed point, how many ways there can be 2 fixed points, how many ways there can be 3 fixed points, and how many ways there can be 4 fixed points. We will add these numbers and we will subtract this from this 24, then we will get the total number of bijective functions from A to A where there is no fixed point. Okay, first one is when there is 4 fixed points. When there is 4 fixed points, so A maps to A, B maps to B, C to C, and D to D. How many ways this can be possible? This is possible only one way, so 1. When there is 3 fixed points, so 3 points are mapping to each one of them. So suppose A is mapping to A, B is mapping to B, C is mapping to C. So automatically the other point will map to itself. So this is already the first case. So there is no case where 3 fixed points. So total number is 0. When there is 2 fixed points, how many ways this can be possible? Choose any 2 points from these 4. How many ways you can choose? 4 C2. Right. So there are remaining 2 points. These 2 points, if they don't want to be fixed point, then one point will be mapped to the other one. Suppose we are choosing A and B to be the fixed points, then we have C and D remaining. So C will map to D and D will map to C. I am giving just one example. So this can be possible in one way. So total number way where there is 2 fixed points, so it is 4C to 6 into this can be done in one way, so 1, so it is 6. Now where is 1 fixed point? So choose 1 point from 4. How many ways? 4C1 4. Now there are 3 points remaining. Now 3 points they don't want to be fixed point. Suppose I am giving an example A, B, C. We have D as a fixed point. How can it possible? Suppose A is mapping to C, B is map. There are 2 points remaining, then B and C. Then B will be mapped to A and C will map to B. Another way this can be possible, like A is mapped to B, B is mapped to C, C is mapped to A. Only these 2 ways are possible if there is ABC. So this is possible in two ways. Number of ways where this one fixed point, how many ways this can be possible? 4 into this can be possible in two ways, 2. So 8. So the total number of cases where there are fixed points is 1 plus 0 plus 6 plus 8, which is 15. And there are total by number of bijective functions 24. So the cases where there is no fixed point is 24 minus 15, which is 9. So 9 is the answer. Question number 6. A 4-digit number is represented as ABCD. That means A into 10 to the power 3, B into 10 square plus C into 10 plus D, where A non-zero. This number DCBA obtained by reversing the digits of ABCD is 9 times ABCD. So DCBA equal to 9 into ABCD. We have to find the number ABCD. As DCBA and ABCD, these are 4-digit number. So A must be less than equal to 1, 5. Suppose A is equal to 2. I am taking A is equal to 2. Then DCBA equal to 9 into 2. Suppose something. This is getting a 5-digit number, 18 something. I'm taking just one example. So this is a 5-digit number, but DCBA is also a 4-digit number. So A must be less than equal to 1. But A is not equal to 0, so A is 1. This is fixed. Then D must be equal to 9, because when I am multiplying 9 with a number starting with 1, then there is 3 other numbers. This is equal to 9 and something. From 0 to 9, 9 is the only integer with which if you multiply 1, you will get a 9. So D is also a 9. So we have got A and D. B is also less than equal to 1, because suppose B is greater than 1. Suppose B is 2. I am taking B as 2. Then 9 into this number, A is 1, B is 2, C is, I am writing C, and D is 9. Then this is greater than 10800, which is a 5-digit number, so it can't be possible. So B is also less than equal to 1. Now we will check two cases. One case is B equal to 1, and other one is B equal to 0. So first case where B is equal to 1. When B equal to 1, then it will be 9 into 11C9 implies 9C11. So this implies 9C plus 8. This has unit digit as 1. Why? Because when you are multiplying 9 into 9, 1, so there is a 8. So when you multiply 9C plus 8, it will be something number where unit digit is this one. So 9C plus 8 has unit digit 1. So this implies 9C, it has unit digit as 3. How I am getting this? Because if there is suppose a number where the unit digit is 1, if you subtract 8 from this, you will get 3, and there will be something number here, some x will be here. So from this reason we are taking it as 9C has the unit digit as 3. Now this implies C is equal to 7, but 9 into 1179 is not equal to 9711. So we have the other case where B equal to 0. Then 9 into 10C9, it is equal to 9C01. So this implies 9C plus 8, this has unit digit as 0. So this implies 9C has unit digit 2, because with the same logic, if a number is ending with 0, if you subtract 8 from this, there will be a 2 and there will be some x on the hand. So 9C has unit digit 8. So this implies C is equal to 8. If C is equal to 8, then 9 into 1089, yes, this is equal to 9801. This is true. So ABCD is actually 1089. This is the answer. Question number 7. A computer password requires to use exactly 1 uppercase letter, 3 lowercase letters, 3 digits and 2 special characters. Total 33 special characters. In how many ways you can create such a password? So there is 1 uppercase letter. So there are 26 letters. We can choose 26 one ways. There is 3 lowercase letters. So from 26 letters we can choose 26 3 in that ways. 3 digits, total 10 digits. From 10 we can choose 10C3 and 2 special characters. There are total 33 special characters, we can choose 33C2. So there are total 9 characters we can use. So the password will be 9 character long. Total number of ways we can create a password is 26C1 into 26C3 into 10C3 into 33C2 into, there are total 9 characters. They can be aligned in 9 factorial ways. So we can create such a password in these number of ways. You don't have to calculate this, you can keep this in this way. This is the answer. Description for the following questions 8, 9, 10. X is the number of success out of n trials where the trials are independent of each other. The probability of success of every trial is P. The probability that there will be exactly K success out of n trials is given here. The expected, this is called the Bernoulli trials, and this probability distribution is called binomial distribution. Expected number is given here. So given that probability that an individual will default on his or credit is 1 by 10. So we are defining success as defaulting credit. So probability of success is given 1 by 100. So what is the probability that out of 200 debtors of the bank, there will be at least one credit default in a year? X is the random variable which denotes number of defaults per year. So we have to find that probability of X is greater than equal to 1. That means that there is at least one credit default in a year. So we can write this as 1 minus probability of X equal to 0. Now probability of X equal to 0, this is given here, the formula is given here for probability of X equal to K. So similarly we can write 200C0 P to the power 0 1 minus P whole to the power 200 minus 0. So this is 1 minus 200C0 is 1, P to the power 0 is 1, 1 minus P is 1 by 100, so 1 minus P is 99 by 100 and 200 minus 0 is 200. So the probability that out of 200 debtors of the bank, there will be at least one credit default in a year is this one. This is the answer. For question number 9, from the situation of in the previous problem, what is the expected number of defaults? Expected number formula is given here, E of X is equal to NP. Total number of cases is 200, P probability is 1 by 100, probability of success, so this is equal to 2. So this is the expected number of defaults. Question number 10. The bank earns 10% of the loan amount for every loan that is repaid. If the person defaults on his credit, then the bank loses the entire loan amount. What is the expected revenue of the bank from a loan of 1 lakh? So for the loan of 1 lakh rupees, earning of the bank earns 10% of the loan account if it remains. So 10% of 1 lakh is 10,000 if loan is repaid. If this is a default case, then bank loses the money. So this is minus 10,000 if it is default. For this loan, the probability of defaulting is 1 by 100 and probability of repaying the loan is 1 minus 1 by 100, so it is 99 by 100. So the expected revenue, you can write this as this. It is, if loan is repaid, probability is 99 by 100 is into 1000 is 10,000 plus probability of default 1 by 100 into earning of the bank is minus 10,000 if it is default case. So if you calculate this, you will get 9800 rupees. The revenue, expected revenue of the bank for a loan of 1 lakh is 9,800. This is the answer. So I have completed the first 10 problems of the part B of CMI M.Sc Data Science 2018 paper. I hope this was helpful. Please press the like button if you like this video. Share this with friends who are preparing for this exam, this session. Check the previous videos of M.Sc, CMI, M.Sc Data Science and also the ISI MSQMS playlist. Please subscribe the channel if you have not done yet. and press the bell icon to get all the notifications whenever I upload a new video. So in the next video there will be the next 10 problems, last 10 problems of this paper. So stay tuned for that. Thank you for watching. See you in the next one. Till then, goodbye. Thank you.